So welcome to the second talk in the session. Again, we have a former keynote speaker, Jeff Payne, and now he's going to give us an introduction to OpenCar.
Thank you. And I've set my timer. OpenCar is perhaps a bit out of place at a Qt Developers Summit because we have been focused heretofore on HTML development. And so what I'm really going to show you today is a JavaScript environment for applications and visual profiles, which we're next taking into Qt territory. And I'll give you some hint of how that's going to work. After introducing the platform, we are aiming to create the industry's first sort of complete ecosystem for automotive application development. And when we think about applications, we're not thinking in terms of infotainment, streaming media, connected applications like you would see on your smartphone. And like Android Auto and CarPlay are delivering first. We think more in terms of features. An application without a state machine. Applications being all of the go-to features that you've seen on your car, as well as those connected applications brought in. There has been, up to this point, an infotainment focus. It's all about brand differentiation, creating software development to efficiency overall, and control and future-proofing for the automakers. The idea being, let's spur innovation, speed application development, and reduce costs. So there's a few key challenges that automakers are up against. The key is they are struggling with differentiation. And as we were discussing this morning, this gets worse and worse over time as consumer expectations for in-car infotainment systems are effectively accessible mode versions of smartphone apps. We see this very much as, I guess, the first phase of the connected car. The second phase has not yet arrived. The recognition that the car is a completely unique new category of device with capabilities that the smartphone simply can't have. And so we're trying to set the stage for this and creating a set of tools and services that will allow individuals like yourself to create the next generation of user experiences. So these are the software development lifecycle is sort of the way that we look at the overall suite of tools that need to be created in order to satisfy this need. And again, the goal is to have the same tools in use by the automaker, by the Tier 1, by any of the individual contributors, Tier 2s, by the third-party content providers, so that they can collaborate with one another, and so that they can stop worrying about workflow and start exercising their imagination. So what does it take to create the basic tools and services that sort of fuel the imagination? There is no explicit support for Qt at this moment, but watch this space, it's coming. Right now there are three legs of this stool. There is an in-car application framework. It's based on Qt Web Engine. Actually is a JavaScript application environment that runs inside Qt Web Engine. There is a middleware layer that supports the service-oriented architecture of that offering as well. The second piece, there's a software development kit that anyone can download. There's no questions asked. The whole point is to expand the pool of developers and to try to, using the third leg of the stool, the service, try to make it appealing to create something new. Use that telematics data that you know exists and imagine something new. This is kind of a Web 2.0 philosophy. When Google opened up the map APIs, they themselves, the smart guys, said, we don't know what's going to happen next week. And lo and behold, the next week, there's a lot of great ideas. From developers in the shower, weekend warriors that were knocking out incredible mashups that we would have never imagined. So our job is to create the tools and to step back and enable the flow. A real key piece of the platform, unlike smartphones, in which you can download an SDK, you can create a project, you can push it up to the App Store, it's curated to a certain extent, it has to pass the App Store policies. But when it emerges on the other side, you're live, you're done. Well, automotive is a push-pull model. Automaker brands are associated with anything they put in their car. If it doesn't work, they have problems. So we have created an application submission mechanism that allows you to certify your application, ensure that it is going to be compliant with the face, the user interface that they put on it, and then allows them from the other side to discover your submission, apply their user interface as simply as possible. And if they like it, pick up the phone, call you, say, who are you? Like your idea? Let's get together. Pull it on through. Curate it into their next vehicle. So it's critically important that we not only create the framework components that address all of the sort of common services. Obviously, you'll have to think about process isolation, and you want abstracted access to underlying media services. Persistence is going to show up again and again. And so let's just create a set of classes that allow any developer to easily hook up to those services. Creating your app logic, this is really where the ingenuity lies. You have a content service, you have let's say an online piece, a bit of data that you want to expose in the car. You create business logic, and you test it out on some application interfaces that ship with the SDK. There's two of them. One's called hydrogen. It's as simple as it gets. One's called oxygen. We're creating another one called nitrogen right now. We don't go into the heavy metals because, again, we're not user interface guys. We don't have the capability in-house to create that level of richness. And so we're very modest about our aspirations for user interface design. But we do know that the OEM and Tier 1 are going to get together to create HMI profiles that will marry up with the developer application business logic, utilizing the framework, and creating a useful application at runtime. So what does that get you? Well, there's some very nice advantages to this, this approach to layering. For one, if you're an automaker, you can do HMI facelifts. You can run analytics and see what's working, see what isn't, and update that component separate from the other components. If you're a Tier 1, this is particularly interesting because you're trying to create a set of sort of core values that you can sell to multiple automakers. If you're an automaker or a Tier 1, you don't know what operating system and hardware you're going to be using next year. And so you want an easy way, without disturbing the rest of the stack, to change all of that out. Pretty simple. So the integration layer becomes a key piece. And the integration layer exposes a set of services in as standard of a way as we can anticipate currently, given the operating environments that we've looked at. We've looked at Android, Windows, obviously Unix, all of the Linuxes that we can get our hands on, and various Geneva stacks to baselines to baseline our assumptions against. And we expose a set of services using the WebSocket and HTTP and 8-bit clean raw binary interfaces on the top through this integration layer. Qt WebKit, web engine. Qt sits on top. The dashed lines are the binaries, by the way. And we have an integration profile that looks down. This is a mapping to the hard buttons and the steering wheel, the voice integration model, the telematics that are specific to a vehicle. And then we have an HMI presentation profile that sits up on the top. This is the on-screen animations, the control library, and all of the behavior on screen. And so the automaker actually creates this HMI integration profile and presentation profile and wrappers the individual applications, the business logic with it. And at runtime, it all links together and executes. By the way, you can swap out WebKit or Web Engine for the next generation as well. We need to anticipate that. So this is what it looks like. Bit of an eye chart. We should actually come back to this. This is hooking up to some of the underlying Geneva services. We'll hit this again at the end. Again, just looking briefly at some of the obvious benefits here. This is HTML5 to get started. And HTML5 appears at the outset to be adequate for many of the base functions. It doesn't provide the richness, even with, I think, the continuous evolution of WebGL, the richness, the stability, the assurances of platform-level security, overall performance that we would see from Qt interface sitting up at the top. But it's the logical place to start. We have cloud services that complement this for update, for monitoring, analytics generation. And of course, we have a very broad way of looking at all of the applications on here. There are reference applications for climate navigation, radio, phone, and at least some basic system connectivity settings, Wi-Fi, Bluetooth. So what's interesting about something like this, if you look at the Bluetooth settings, for example, why would I want to update those after the car ships? Well, it's a 12-year life cycle on new cars. They last a long time. And we don't know what is going to be popular 2 years from now. We know that right now I should be able to hook my Bluetooth, my Pebble smartwatch up to my car. Now, how would I enable that as an automaker? If I want to continuously improve the user experience so that my customers remain so satisfied that they come back to my showroom in 5 years, I'm going to have to push an update that now accommodates a pairing with a particular device ID, the Pebble smartwatch, and sends the appropriate data over to that watch, if I so desire, if that becomes a competitive imperative among automakers. Another nice advantage of this approach is that most of the components in the stack are relatively static. When you ship the car, we know one thing. We know that everything is going to change over the course of time, and it needs to remain stable because the automaker is going to have a black eye if the APIs aren't well defined, if validation doesn't work, and they try to move too quickly. Well, the middleware, and this is using a test case of the Mazda 3 integration. Middleware added up to about 5 megabytes. The framework itself, those JavaScript libraries that provide functions like persistence, about 12 megs, not all loaded into memory at the same time. The HMI profile for the applications, primarily infotainment applications, but a nice cross-section of different application categories, adds up to about 5.5 megs or so. The application logic, this is a sample of 40 applications, about 200 kilobytes of unique data. So if I'm going to be revving an application over some course of time, I need to know where to look for the variables. And having a stack that's relatively stable, this is a proportional stack here. The app sliver is purposely indicated as slim. I need to be able to look at the data that changed and know what hasn't changed. And I want to have the help of some automated certification as well. So, another consideration. Building a new system. When automakers build a new system, it's about an 18 to 21, 22, sometimes 24, 25, 26 month period of a variety of activities. Some of it business, some of it organizational, a lot of it really head-down diligence, really focused development. And this is a horribly oversimplified depiction of some of those activities. Right now, most automakers don't, or most tier ones, I should say, don't really think hard and long about how to support this in post-production. This kit, one of the goals is to provide the basic libraries that help us to compress that overall development schedule because we have reference profiles, reference applications, we have a simulator, a simulated environment that we can actually have some confidence actually represents the target device. So we're running more and more of our processes in parallel, and potentially, once there's confidence in time among tier ones who have to stand behind this product ultimately, potentially compressing this 18 to 21 month development schedule down to 12, perhaps 15 months. And then of course there are provisions for post-start of production support included as well. The simulator that I talked about is running the, let's see, is this the Oxygen? No, this is actually the Mazda profile, Day at a Glance. Day at a Glance, this application took us about 4 days to code up, including the artwork. It's a relatively simple application, granted, but one of the reasons that we could move as quickly as we did, and by the way, I should mention the people who created Day at a Glance are not the same individuals that created the platform. They are new folks that we brought in that were using the SDK and learning as they go. This is a clock, calendar, and a couple of other functions wrapped up in a skin, an HMI visual profile that is part of the Mazda 3 profile. It's running on a simulator that depicts the bezel and the commander and the steering wheel buttons and all of the telematics variables that are actually supplied by that particular vehicle. And so when a project begins, the very first thing that has to happen is that an HMI profile has to be created. This is not a refined science yet. I'm not going to elude you. We have been doing these manually. We're putting together some automated, some more refined tools for dragging and dropping, for creating quick control libraries, for dressing them, etc. Again, in HTML5, and it's only so interesting to pursue that up to, we'll pursue that up to a certain point. But when this simulated environment is complete, we have a lot of pieces here. We're able to switch out the UX profiles, the upper right corner. We're able to switch out the commander, bezel buttons, steering wheel buttons, that sort of thing. We can very quickly dress new ones and creating a new profile. We're able to go out, if we happen to have that car, we can go out with a canalizer, grab actual CAN data, bring it into the environment, where it's parsed in and normalized actually into sort of a standardized telematics set. Our primary focus is the W3C telematics set. Actually, OpenCar and Intel co-chair the W3C working group and business group. And so much of this already is our technology in W3C. Coming out of this, we're able to pretty quickly create program bundles. I'm going to scramble ahead here a little bit. I'm going to just tell you very briefly about the program management feature that's provided by Inside Track. Again, I hope that everybody will go up and play with it at some point after the conference. This is an automated certification that we're able to run at the end of a project to ensure API compliance. This is important for a number of reasons. Some of the profiles that are provided and the interfaces that they enable with common app logic. Kind of a close-up of that simulator, looking at it from different perspectives, this goofy game controller thing that I hope we'll get rid of one day. Here's Mazda. And again, the telematics profiles for each of these are, the first two are simulated cars for development, so you can ensure that your application does work consistently across both profiles, so that third profile will actually work. We're building a larger and larger pool of business logic to drive these various profiles. Not a particularly interesting HMI example, I think. This is actually the Volvo census system. We're building a profile, multi-tab, multi-application profile for vertical screen called Nitrogen. That'll be available in the kit very soon. W3C, we talked about that already, some of the other stuff. And the base HMI applications. When we start thinking about this, why do that? Well, okay, just think about terrestrial radio and the metadata that comes across. We're a connected system now. Why do we want to update this? Because we may want to introduce more and more and more capability to the system that's available on the brand car to bring you back to the showroom again. So back to this. This is a bit of a drill down on some of the modules that you can access, the APIs that you can access via the SDK. Sitting up at the top here, we have application business logic, MVC style program construction, sitting underneath the presentation profile, accessing the core framework components, which in turn talk to this layer here, middleware layer that sits on top of the hardware. Underneath this middleware layer, we go down and we talk to the underlying devices, and there's a growing library of C interfaces to kind of speed the integration for tier ones. Okay, pure HTML. This is where we are moving next, and we're in early experiments right now, where we are actually here. Let me step through this once at a time. A C application, a Qt application using the runtime alongside the HTML apps. This is where we are currently. This integration layer, the exposed WebSockets and HTTP interfaces, we're opening up slowly but surely, documenting those APIs so that Qt developers can actually sit on top of this service interface and gain some of the portability advantages that you might see from that sort of thing. And this is, of course, where we want to go next, is to use Qt Quick and use common business logic authoring style to drive either HTML5 or Qt. That is, I think we're probably looking at mid to late 2016 for that to get wrapped up. We need more help. So there it is in a nutshell.
So we still have a little bit time for a few questions. Any questions? I don't see any, so I just have one myself. One thing I always wonder about: how is a driver supposed to interact with such an rich entertainment system, control system? Because when I'm driving, I always looking for the knobs and try to not look there.
Yes, yes. Well, simplicity is key. That's not an answer for me to provide. I know, it sounds like I'm dodging it, but notice that I don't try to present graphics, anything really graphically rich. We have a community right here that lives in the world of user experience. You're masters of the user experience, the key enabling technology. I do know that less is more in the world of automotive, clearly. We hear this every day until we're terribly tired of it. But richness is going to be the key for differentiation for the individual brands. Again, CarPlay and Android Auto are not helping the automakers, but they're a convenience that is irresistible to automakers. Long term, they disintermediate the brand. So what do automakers do about this? The overall user experience, the way that we interact with these systems, those are going to be the key differentiators for automakers. It's for this group to address.
So, something for everybody to think about.